Okay, so the next problem is 15, and I'm just going to write it right on the paper because it already gives us a diagram, so why not use it? This one was a little bit tricky, but once you figured out the trick to this, it wasn't terribly difficult. All right, so it says triangle ABC in the figure has area 10. Points D, E, and F all distinct from ABC are on sides AB. Okay, so that's just showing us where it is. And so it's irrelevant, pretty much. And AD equals 2, DB equals 3. Important information, let's write that down. AD is 2, DB is 3. If AB and triangle ABE and quadrilateral DBEF have equal areas, what is that area? So, what are they talking about? This is ABE. This is the ABE they're talking about, this triangle right here. And this quadrilateral right here. And those have equal area. Well, if these two have an equal area, they're going to overlap in this region right here, this quadrilateral region. So basically, that means that's the same thing as saying these two triangles are equal. Let's just call this like point P or something. It doesn't really matter. So basically, APD is the same area as EPF. So what can we do with an equal area? What we're going to do is we're actually going to try and prove parallelism. That this line is parallel to this line. Right there. AC is parallel to ED. How do we do that? So if we know that these two triangles have equal area, we know that these two triangles have equal area. Or here, let me write that down. So we have that APD has the same area as EPF from this right here. And by addition property, we can add the same area to both sides. So triangle AFE is equal to the area of AFD. So what do we get with this? Because we know that these two have an equal area, we know that the height is going to be the same because they have the same base. How do we find the area of a triangle? We take 1/2 base times height. If the two bases are the same, let's take AF as the base because they share the base. We know that the height has to be the same if their areas are the same. So let's draw the heights. The height to this triangle would be this right here. And the height to this triangle would be this right here. And we know that these are supposedly equal. And because they're heights, these are right angles. So that means that this whole thing forms a rectangle. And therefore, these two lines have to be parallel because, well, lines in opposing sides in a rectangle have parallel sides. So now that we know that AC is parallel to DE, what we want to find is the area of either ABE or quadrilateral DBEF. Which one looks easier? Probably triangle ABE. So let's start with that. We know that the entire area is ABC equals 10. So if we just want to find this area, all we really need to know is this ratio, the ratio of CE to EB. And then we can basically figure out the entire area. Well, these two are parallel, and this is segments DB and AD are in 3:2. Then we know that these two also have to be 3:2. Why is that? Well, because once we have similar triangles, or once we have parallel lines, these two angles are equal, and well, that's already enough. Once we have these two angles are equal, we have that triangle BED is similar to triangle BCA by AA similarity because they share angle B. So just by that, we know that triangle BED is similar to triangle BAC. That means that the ratio of the sides are going to be the same. So the ratio of this 3 to BA is going to be 3/5, and that means this to this is going to be 3/5. And because of that, the area of triangle AEB is going to equal 3/5 of the area of triangle ABC. And because we know the area of triangle ABC is 10, we take 3/5 of 10 and we get area ABE equals 6. And that's our answer. Another thing you could do when you approach the problem is notice how they don't express your answer as blah blah blah. That can make you already assume that because it's math counts, obviously this won't work for other competitions, but for math counts, what you can assume is that it's going to be an integer. If it's going to be an integer. And obviously it's less than 10, it's probably around 5-ish, but definitely not less than like 3 or more than like 7. So you can already guess that it's going to be somewhere in that region. And if you really want to take a shot at it, you'd go 6. So that concludes homework number 4. I hope you guys found these videos helpful, and thank you very much. Give me feedback.